This is Dr. Ravindranath Reddy. In this video, we will study how to evaluate the double integral using change of order of integration. Before going to solve the problems, we will see what is meant by change of order of integration. So change of order of integration means that just interchanging the limits of the integration without changing the region of integration. For example, we take a double integral x is equal to a to b and y is equal to y1 of x, y2 of x, f of x comma y dy dx. For this double integration, if you apply the change of order of integration, we will get integral y is equal to a to b and integral x is equal to x1 of y and x2 of y, f of x comma y dx dy. Now once if you observe this above integral and this integral, so in the above integral, we are having x limits are constant. After changing the, after applying the change of order of integration, then we have converted the x limits in terms of y. And similarly, in the above integral, we are having y limits in terms of x. So once after applying the change of order of integration, we got y limits as constant. So changing the limits of integration is nothing but the change of order of integration. So now we'll take one example. Change the order of integration and evaluate integral 0 to 1, integral x squared to 2 minus x, xy dx dy. So this is the given double integral. So first we have to apply the change of order of integration and then we have to evaluate this double integral value. Now once, if we observe this double integration, the inner integral having the limits in terms of x. So, and then these limits are limits of y. Now, we'll take the region of integration. So, the region of integration is bounded by these four limits, which are given by y is equal to x square, y is equal to 2 minus x is equal to 0, and x is equal to 1. So, now once if we observe these four limits, so in this we're having two equations which represents the curves. That is y is equal to x square and y is equal to 2 minus x. Now we'll draw this curves in xy plane. Now we'll get, so this is x-axis and this is y-axis. Now this y is equal to x square represents a parabola symmetric about y-axis. Now y is equal to 2 minus x. It is a straight line. It is a line which passes through the points 0, 2 and 2, 0. So which is, this is the straight line whose equation is y is equal to 2 minus x. Now this is the origin 0, 0. Now once if we observe this line and the curve, parabola curve intersecting at this point. Now we have to find out the point of intersection of these two curves. Now, in order to find out the points of intersection of these two curves, we have to solve these two equations. Y is equal to x squared and y is equal to 2 minus x. So if you solve these equations, we can find out the points of intersection. Now, you consider this one as equation 1, y is equal to x squared, let it be equation 1. Y is equal to 2 minus x, let it be equation 2. Now, you substitute this y is equal to 2 minus x in equation 1. You will get x square is equal to 2 minus x. So we can rearrange these terms. So you will get x squared plus x minus 2 is equal to 0, which is a quadratic equation. Now solve this quadratic equation. You will get the values of x here. So we get x is equal to minus 2 and x is equal to 1. Now, by using these x values, we will find out the values of y. Now take x is equal to 1. So when we substitute x is equal to 1 in equation 1, then automatically you will get y is equal to 1. And similarly, substitute x is equal to minus 2 in equation 1, you will get y is equal to 4. But in our problem, the x value varies from only from 0 to 1. But here we got x is equal to -2, which not satisfies this condition. So in the problem he has given only x varies from 0 to 1. So because of this reason, I want to neglect this x is equal to -2 here. So when we neglect x is equal to -2, then you will get only one point, that is 1 comma 1. So 1 comma 1 is the intersecting point of this parabola and the curve. So this is the point A of 1 comma 1. So this is the intersecting point of these two curves. Now we have to identify the region of integration bounded by these four limits. So this is the region of integration which is bounded by these four limits, which are represented with capital R. Now in the problem, we're having y limits are in terms of x. So whenever we have y limits in terms of x, we have to draw a vertical strip parallel to y axis in the region capital R. Now we have to apply the change of order of integration. When you apply the change of order of integration, then this vertical strip will be converted to horizontal strip. So here we were having this horizontal strip here. So now we are applying the change of order of integration now. So we have applied. Now this vertical strip is converted to horizontal strip. Now once if you observe this vertical strip, I want to slide this vertical strip from point B. So when we slide this vertical strip from point B, one end of the strip is on the y-axis and the other end of the strip is underlined. So now the strip is moving from point B to A. Now from the point A, the strip change, one edge of the strip is changing from straight line to it comes on the parabola. Okay, so whenever the strip of one edge jumps from one curve to another curve, then it indicates that we have to divide this entire region capital R into two subregions. So that two subregions are given by area of AOAC plus area CAB. So this is one sub-region and this is another sub-region. So after dividing this into sub-regions, so in the first sub-region, we have to draw one horizontal strip, and in the second sub-region, we have to draw another horizontal strip. Now, I'm taking this sub-region, which is bounded by these points O, A, C, O. So imagine that this is a subregion R1, which is bounded these points. And if you observe this R1 region, in this R1, the y value varies from, initially the y value is 0. And at this point A, we are taking the y value is 1. So from this, it is clear that y limits are constant, which varies from 0 to 1. And now we'll find out the limits of x in terms of y. So in R1 region, where the curve, the parabola curve is involving in the region R1. So since only one curve is involved here, that is a parabola, from this parabola curve, we can get x is equal to root y. And similarly, so we are here having x is equal to 0, that is nothing but y-axis throughout this region we are having. So we have to consider the y limits, x limits varies from 0 to root y. And similarly, take the subregion to R2. So in this region, if you observe the y value, initially the y value is 1, and at the point B, the y value is 2. So from this, it is clear that the y value varies from 1 to 2. And whereas in R2 region, only this line is involved in R2. So from that line, we get x is equal to 2 minus y. And this x is equal to 0 is also same for this R2 region. So from this, it is clear that x value varies from 0 to 2 minus 1. Now, this is the given definite integral. So we are dividing this integral into two regions. We are taking this double integral over two regions. One is double integral over OACO plus the second double integral over the region CABC. Now in this, we'll replace these regions with its limits. So the first region limits are y is equal to 0 to 1, integral x is equal to 0 to root y. And if you come to the second region CABC, the limits in this second region, y varies from 1 to 2 and x varies from 0 to 2 minus y. Function is xy dx dy. Now we have to evaluate these two double integrals. So since x limits are in terms of y and y limits are in terms of constant, then first we have to apply the integration with respect to x. Okay, so we know that whenever we are applying integration with respect to x, we have to consider this y as constant. And similarly here also we have to consider y as constant. So I want to take this y outside this integral. So it becomes integral x is equal to 0 to root y. When you take y outside, the remaining one is only x. So x into dx. In this second term also, we will get the same integral. Integral x is equal to 0 to 2 minus y, x dx into dy. Now we know that integral of x dx, that is nothing but x squared by 2. So we got integral y is equal to 0 to 1, y into x squared by 2, and we have to substitute the limits of x, that is root y 0. And similarly in the second integral also, we're having the same integral value. Integral of x is x squared by 2 and the limits are 0 to 2 minus y. Now substitute the limits, upper limit and lower limit here. So when we substitute the upper limit root y here, so root y whole square, this square root and power 2 gets cancelled, you will get only y by 2. And if you substitute the lower limit y x is equal to 0, so this x square becomes 0, 0 by anything equal to 0. So we will get only y by 2. Similarly, in this integral also, you substitute the upper limit 2 minus y in place of x. So you will get 2 minus y whole square by 2. And substitute the lower limit in place of x, you will get 0. So finally, you will get 2 minus y whole square by 2. Now, simplify this, you will get, so since this denominator is 2, which is a constant, so I want to take that the denominator to outside, so it becomes 1 by 2, and integral y equal to 0 to 1, and here we are having y into y, so that can be written as y square into dy plus 1 by 2 into integral y is equal to 1 to 2, and you expand this 2 minus y whole square. After expanding this, you multiply with this y. So you will get that value is equal to 4y minus 4y square plus y cube into dy. Now apply the integration with respect to y between these limits. So here you are having y square. So integral of y square can be written as y cube by 3. So 1 by 2 into y cube by 3, limits 0 to 1 plus 1 by 2 into, now individually you apply the integration for each term. So integral of 4y, that can be written as 4 into y square by 2 minus 4 into integral of y square, that can be written as y cube by 3 plus integral of y cube, which is given by y to the power of 4 by 4. We have to substitute the limits, lower limit and upper limit here. Now after substituting the upper limit and lower limit here, so first you substitute y is equal to 1. So you will get 1 cube, that is nothing but 1. So 1 by 3. And the lower limit is 0. If you substitute y is equal to 0, you will get 0. So 1 by 3 minus 0, that is nothing but 1 by 3 plus 1 by 2 into, in this also you substitute the limits, y is equal to 2 and y is equal to 1. First substitute the upper limit here, y is equal to 2. So you will get y square, that is nothing but 4 by 2, which is equal to 2. 2 into 4, 8 minus 4 by 3 into 8. It becomes 32 by 3 plus 2 power 4 by 4. So you will get that value is equal to 4. So this is the value after substituting the upper limit. Now minus, substitute the lower limit here. So wherever we have y, just replace y with 1. You will get 4 by 2, that is nothing but 2 minus 4 by 3 plus 1 by 4. Now if you simplify this, finally you will get that value is equal to 3 by 8. So this is the way how we have to apply the change of order of integration and how to find out the double integral value. Thank you for watching.